your computer freezes. You search the problem, and no matter what's actually wrong, no matter what page you land on, the very first suggestion is always the same words. Turn it off and on again. It feels like a non-answer, like nobody actually diagnosed anything, so they're just telling you to mash the button and hope. But here's the thing, it works. Constantly, across completely different problems, on completely different devices. Your laptop, your router, your game console, a printer that's somehow jammed on nothing for reasons that don't even resemble each other. So what's actually happening underneath all of that? Start with the most common case. Your computer just freezes. Cursor spinning, nothing responding, no error message, nothing to click. Your computer keeps two very different kinds of memory. One is long-term storage, your actual programs and files, sitting there patiently whether the power's on or not. The other is short-term, active, working memory, and it only holds what it's holding because it's constantly being fed power. Cut that power, and everything inside it vanishes instantly, no trace left behind. Now, a bug can poison what's sitting in that active memory. Maybe a value gets lost. Maybe two parts of the program collide trying to update the same thing at once. Either way, what's actually stored no longer matches what the program expects to find, and it simply stops, waiting on a state that no longer makes sense. But here's the important part. That bug can only poison what's sitting in active memory. It can't reach back and rewrite the actual program sitting safely in long-term storage. The instructions themselves are untouched the whole time. So, when you cut the power, you're not fixing the bug. The flaw in the code is probably still sitting there, waiting to happen again someday. What you're doing is destroying the specific mess that one bug happened to make, completely and instantly, and then reloading the original, untouched instructions from storage, and starting clean. Different mess next time maybe, but this mess, gone. Not every problem is one sudden corruption though. Some build up slowly, which is a genuinely different mechanism. No single freeze moment to point to it all. Programs borrow memory and other resources from the operating system while they run, and they're supposed to give it back when they're done with it. Sometimes because of a bug, they don't. A browser opens a tab, allocates some memory for it, and when you close that tab, a few scraps of that memory never actually get released. An app opens a connection to something and forgets to close it properly when it's finished. Individually, each of these is tiny, harmless even, but leave the computer running for hours or days, and those tiny unreturned scraps quietly pile up, a few kilobytes here, a few there, thousands of times over, and eventually the system just starts running out of what it needs, and that can cause a freeze too, until there's meaningfully less actually available than there was that morning. Everything starts to visibly drag. Things take longer to open. Eventually something can fail outright once there's nothing left to give it. Same underlying idea as before. The leak itself doesn't get fixed, but a restart resets the count back to zero all at once, reclaiming everything that was quietly lost, and buying you another few hours or days before it creeps back up. This, by the way, is the real reason your phone or laptop tends to feel sluggish the longer it's been left on. Not your imagination and not aging hardware, just quietly accumulating debt, paid off the moment you restart. Here's where it gets more interesting, because this exact same idea shows up somewhere most people never think to look. Your router has a computer inside it. So does your printer. So does your game console, your smart TV, your thermostat, practically anything with a blinking light on it. They're just tiny, and instead of running whatever you happen to install, each one runs one small, permanent program, built once by whoever manufactured it. These little devices get stuck constantly, a drop signal mid-transmission, a rare sequence of events nobody happened to test for. And here's the manufacturer's actual calculation. Since unplugging it is always an option for whoever's holding it, they often don't bother building graceful recovery from every possible bad state. Instead, all that effort goes into one path, made as bulletproof as possible. The full startup sequence, reinitializing every chip, clearing every register to its default, reloading the one known good program from permanent storage. That path gets tested obsessively because it has to work every time, for every customer, forever. So restart your router was never superstition, and it was never a guess. It's forcing that tiny program through the one path its own manufacturer actually tested the hardest. And this isn't just something you personally get to use when you're stuck. It's a deliberate engineering strategy, used on purpose at a much bigger scale than one laptop. Plenty of hardware includes something called a Watchdog timer, a tiny circuit whose only job is noticing when the main program stops responding and forcing a restart with no person involved. Spacecraft have them, industrial machinery has them, medical equipment has them. Anywhere a device might run for months with nobody around to notice it's frozen, and entire data centers run on a version of the same idea, just at a much larger scale. When a server starts misbehaving, engineers frequently don't spend expensive time diagnosing exactly what went wrong on that one particular machine. It's often cheaper and more reliable to just end it and stand up an identical, known good copy in its place from the same template every other server was built from. There's actually a name engineers use for this mindset: treating machines like cattle, not like pets. You don't nurse a sick one back to health and learn its individual quirks. You replace it and you move on. The exact same logic as unplugging your router, just running automatically across thousands of machines without anyone typing a single command. So the next time the advice is turn it off and on again, it's not that nobody knows what's actually wrong. It's that, most of the time, it genuinely doesn't matter what's wrong. Corrupted memory, a slow leak, a wedged piece of firmware, an unhealthy server somewhere in a data center you'll never see. Different causes, same fix. Wipe the mess, start clean.